All right, we took data over can you taco tongue or evil eyebrow. This was the raw data for third and fourth period. And using that data, we were able to fill in the blue of our two-way table. And we used those values to fill in the red. So let's go to a Venn diagram. Whenever you have a Venn diagram, so one circle represents yes, taco tongue, the other represents evil eyebrow, yes. And then the rectangle around is the total set. So that would be all of our students in the classes. So you always start with the overlap. The overlap means both. So this is how you start from a two-way table to a Venn diagram. We're going to start there. So that is the both. The evil eyebrow and taco tongue. So that would be found on the two-way table top left. So that'd be 7. And then that whole circle on the left represents yes, taco tongue. So we have a total yes, taco tongue of 22. But 7 of them are yes, evil eyebrow. That's the overlap. So then over here would be yes, taco tongue, but no evil eyebrow. That'd be the 15, because all together I have to add up to 22. And so then the yes, evil eyebrow, but no taco tongue is just the 1. Yeah, because it adds up to 8. And then this little blank outside is who can't do either one. So that would be the neither. We have 4 people who could do neither. So you can use the two-way table or the Venn diagram to come up with your probabilities. It says, suppose that we randomly choose a student from the class, find the probabilities. So yes, taco tongue. How many yes, taco tongues did we have? 22 out of 27. And we can leave it just like that. You don't have to simplify it. You don't have to change it to a decimal. You can leave it just like that. No taco tongue. How many are no taco tongues? 5 out of the 27. Yes, taco tongue, and yes, evil eyebrow. That's a yes and yes.
7.
Yep. Yes, taco tongue, and no evil eyebrow.
15.
Mm-hmm. Okay, yes, evil eyebrow.
8.
Yeah, it's just the 8. No evil eyebrow.
19.
Mm-hmm. Yes, evil eyebrow, and no to taco tongue. Yes, evil eyebrow, no taco tongue.
1.
Yeah, we just had that 1. And then no and no. 4. So 4 couldn't do either way. All right, let's go ahead and find these probabilities. We've already done this before. Yes, evil eyebrow, how many?
8.
8. And no evil eyebrow. 19. So probability of yes, evil eyebrow, or probability of evil eyebrow.
27.
27 out of 27, right? Because it's the whole set. You either can do it or you can't do it. So these are called mutually exclusive. You either can do it or you can't. And we were able to just add them up. We could have just added those up to get to this. If they add up to equal 1, then we know for sure it's mutually exclusive. If it's over 1, then they're not mutually exclusive, and we got to take out overlaps, or the overlapping ones. Suppose randomly choose a student, find probability. So yes, taco tongue. How many did we have?
22.
22. Yes, evil eyebrow.
8.
Okay, so then we have yes, taco tongue, or yes, evil eyebrow. So this is an or. So we would add them. Let's see. If we add them, what happens?
It's more than 27.
It's more than 27.
So do we subtract the 1, 2, 3 both?
Yes. If it adds to more, it's not mutually exclusive. So we do have to subtract out the overlaps. Or the overlap. Subtract both. How many were both? 7? So we do 22 over 27 plus 8 over 27 minus 7 out of 27. Is that what you said? So how many did that end up being? 23? And would that make sense? Looking at our Venn diagram, that would be all of these, and then so it'd be 15 plus 7 plus 1, basically, which is the 23. If you add the 4 that can do neither, that'd get you the whole set, 27 out of 27. So, yes, this is correct. All right, two-way tables and Venn diagrams. We're going to see how they correlate to each other. So I'm going to have you draw on one side a Venn diagram. Oh, let's try that again.
There's a whole lot of space.
No, there's not. And then we need to do a two-way table also. With 2 events. Like a tic-tac-toe board. Okay, so this would be A. This would be complement of A. So this would be B and complement of B, not B. So I'm going to just name these with numbers so we can show where those values will show up on your Venn diagram. Okay, so we'll call the left circle A, the right circle B. So whenever you go from a two-way to a Venn diagram, you always look at the middle. That's your overlap. That's the double. That's the A and B. So that would be 1. The number that's found in that one spot is A and B. It's what can do both. And so we know the whole A, and then we just take away the part that is also B. So if you look at the A row, and so without B, that would be your complement of B. So that would be 2. And then for the B circle, we'd want B, but without A. So B and then complement of A would be the third one, number 3. And then what can do neither is outside the 2 circles in the rectangle before. When you make your two-way table, though, make sure that you include a total row and column. Don't forget that. There we go. Just because that helps you find missing values, missing probabilities. Alright, the general addition rule. Probability of A or B is found by doing probability of A plus probability of B minus the probability of A and B. Because this would be the both. So you want to make sure you don't double count anything. But if the events are mutually exclusive, then you could just add them without taking anything away. So probability of A and B is 0. Then the probability A and B is just found by adding those two. Okay, we can use words or symbols as long as symbols are well defined. So probability of A and B is going to be an upside down U. Almost looks like an A, but without the extra line, or we can call it the rainbow. So that's a symbol for and. The or is union. It's a U. Them together. So I always think about union, marriage, everyone brings all their stuff into the new house. So it's a union. You got both. All right, we are going to use those symbols where we can. And let's go ahead and talk about one more thing. We have two different kinds of or in the world, okay? But we've got to identify which or we use in statistics. So think about when you go to Sonic, they ask tots or fries. But when they ask that, can you choose both or you have to pick one?
Pick one.
We have to pick one. But with Starbucks, they ask, do you want cream or sugar? Do you have to only pick one? No. So the kind of or we use in stats is Starbucks or. So it's not a Sonic or. So cream or sugar means you can have cream, you can have sugar, you can have cream and sugar together. So can choose one or both. All right, so go ahead and work with your partner on the application problem. So let's check and see how you did. So look at our two-way table and the Venn diagram. How did you do on it? Okay, and then the O and the complement of O, you could do it on the top or down the side, either way. So you might have flip-flopped them, and that's okay. Just as long as they're both there. And then probability of O complement. It means the probability a student does not prefer over the role. So make sure you put the probability in, because it's P of, so it's probability of a student does not prefer over the role. Don't write complement because the reader does not know what complement means. You have to be very specific and detailed in how you write it. And then C says probability of O or R. So if we were to look at O, look at R. If we add them together, that's too many. That's over 1. So it's counting our overlaps. And so you want to subtract the overlap, the yes, and that's why I subtracted the 58. And I got 94 over 116. And then probability, write the event does not replace the role, so that's R complement. And, so that's the intersection, prefers toilet paper pulls over the roll, so that's over. In symbolic form and find the probability. So it's 12 out of the 116.